discussing analysis of single degree of freedom system to various kind of forces as well as the system properties of single degree of freedom system. And we were discussing something called as logarithmic decrement as a method to measure damping. Do you remember that?
Sir.
Yeah, but now in order to avoid the monotonous flow of a content, हमने वो आधा discuss किया है. We have already discussed it halfway through logarithmic decrement, but we will start with multi-degree of freedom system, and then at appropriate time we will go back to logarithmic decrement. Are you with me?
Yes, sir.
Okay, so now to understand what do we mean by multi-degree of freedom system, instead of starting with the definition, we will consider the multi-degree of freedom system and then we will try to construct the definition. Are you with me?
Yes, sir.
Okay, so consider a two-story frame. At ground level it is 2 bay, and at the first story it has only 1 bay. Are you with me?
Yes, sir.
Okay, and now I have given all the geometrical properties. This span is 3 meter, this is 2 meter. The height of first story, ground story is 4 meter, first story is 3 meter. And then I have shown some damper elements C1 and C2. So C1 is connected from top of the first floor till top of the ground floor. Are you with me? I'm sorry. Top of it is connected to soffit of the second slab to top of the first slab. Are you able to imagine that?
Yes, sir.
And now intentionally I have shown C1 dashpot model in this fashion, as there is a tendency of relative horizontal motion between these two slabs. Corresponding to their relative velocity, there will be a damping force developed in this damper with damping coefficient C1. Are you with me?
Okay, sir.
Okay. Similarly, the soffit of the first floor slab is connected to the ground. So relative to the motion between ground and this top story, corresponding to relative velocity between these two levels, there will be the force that will get induced in this damper element with damping coefficient C2. Happy?
Yes, sir.
Okay. Now let us go ahead. What are the degrees of freedom that interest us in this particular system? Can you tell me? So single degree freedom के लिए भी हमने ऐसे किया है. We had considered a single story, single bay frame, and in that case, what was the degree of freedom that we were monitoring? Yes, Jitnesa.
Sir, I can't remember it right now.
How can you not remember that? Anyway,
Yes.
so you can keep yourself on mute. I will ask someone else. So let me ask Soham to unmute. Soham, can you unmute? Is Soham there?
Am I audible?
Yes, you are audible. Okay. So what is the degree of freedom that we monitored in this kind of problem? Soham?
Yes, sir.
अरे पुढचं पार्ट मागचं पार्ट असं कसं चालेल? So if you imagine, if you remember, we had monitored this degree of freedom delta. Are you with me?
Oh, yes, yes, sir.
And we called it as U of t. Are you with me?
Yes, sir.
This is U of t. And we had monitored this degree of freedom. We had written down the equation for evaluating this function, U of t.
Lateral displacement, right?
Lateral displacement of the first story. Now here, as you are going to have two stories, so can you tell me what are the displacements or what are the degrees of freedom that interest us? कौन से degrees of freedom monitor करने चाहिए? Soham?
Yes, sir. Lateral as well as.
No, we are going to consider this as U1 of t. This is x directional displacement of first story with reference to ground. Are you with me?
Yes, yes, sir.
And this is x directional displacement of second story with reference to ground. If you remember, we have discussed at length what is degree of kinematic indeterminacy. Then we discussed which degree of freedom is to be chosen for such type of problems as a degree of kinematic indeterminacy. And then we know that the lateral displacement is the only one that we will consider. Are you with me?
Yes, sir.
But as there are two stories now, we are going to consider lateral displacement of each of this story as another. What can you say about ground? Ground is stationary. At least in this scenario, we are going to assume that the ground remains stationary. Are you with me?
Yes, sir.
And now, once we have chosen the degree of freedom that we are going to monitor, u1 of t and u2 of t, answer few of my questions. If a stress or strain, if a stress needs to be induced in column FG, FG में अगर स्ट्रेस होना है तो
Yes.
कौन कौन इन दोनों में से कौन से डिग्री ऑफ फ्रीडम नॉन जीरो होने चाहिए? टेल मी.
So U1 of T.
Yes, even if u2 of t is 0, it doesn't matter. As long as u1 of t is non-negative, it is going to induce stresses in columns FG, EH, and BA. Do you agree with me?
Yeah. Yes, sir.
For example, let us consider an example. Let us say u1 of t is 5 mm at a given instant of time. So let us say at time t equal to 5 seconds. We say that u1 of t, that is u1 of 5, is 5 mm. Are you with me?
Yes, sir.
So then if I were to draw the deformed shape of column GF, it is going to be something like that. Happy?
Yes.
With this as 5 mm. It is going to induce bending moment. It is going to produce bending moment diagram for column FG, and bending moment in turn is going to induce various bending stresses in this column.
Yes,
Do
sir.
you agree with me?
Yes, sir.
And we are talking about bending stresses, not the stresses due to gravity load. So forget about gravity load now. We are talking only about the bending stresses induced due to
Yes.
these lateral deformations. Happy?
Yes, sir. Yes, sir.
Okay. Now, I will ask you another question. What is the displacement that causes stresses in column DE?
U2 of T.
Okay. Now I am going to counter your answer by considering an example. Let us say at time 5 seconds, U2 of 5 seconds is 5 mm. Are you with me?
Yes, sir.
And U1 of 5 seconds is also 5 mm. Are you with me?
Yes, sir.
Let us draw now the deformed shape. So I am drawing column DE. This is its original position. Happy? This is E.
Yes, sir.
Now at time t equal to 5 seconds, this D has moved to D dash, which is at
Yes, sir.
distance 5 mm, and this E has moved to 5 mm because u1 of 5 second is also 5 mm. Are you with me?
Yes, sir.
So it has moved to E dash. Tell me, are stresses induced in this column?
No, no, sir.
Because it is like a rigid body motion of column D. A car that moves by 10 mm doesn't introduce stresses in car parts because all the points are moved by same amount. Are you with
Yes,
me?
sir.
So therefore, what is that which causes stresses in the column DE? किसके वजह से stresses induce होने वाले बताओ? Only you will acknowledge only when u2 of t and u1 of t are different, then only there are
Yes,
going to be stresses in the column. So therefore, it is neither u2 of t nor u1 of t
U1
solely
of T.
responsible for causing stresses in column D. दोनों में से कोई भी एक sufficient नहीं है. We are going to talk about now something called as relative displacement. Are you with me?
Yes, sir.
So relative displacement of D with reference to E is responsible for causing stresses in the column. So you have to understand that U2 minus U1 is the quantity that is responsible for causing stresses in column DE and CB. Do you agree with me?
Yes, sir. Sir, one question.
Yes.
So is it practically possible that U2 of T and U1 of T are same?
Yes, why not? I will give you an example. जरा देखो यहाँ पे. So this is digress. This is not what we were discussing, but as you have raised it out, I will answer the question. Okay. प्लास्टिक एनालिसिस स्टडी किया है कि नहीं आप लोगों ने? आई डोंट नो
Yes, sir.
व्हेन इट इज एडवांस स्ट्रक्चरल एनालिसिस में रहेगा प्लास्टिक एनालिसिस. आर यू विथ मी?
Yes, sir.
Now imagine that due to some lateral load, plastic hinges have been formed at these 4 locations.
Hmm.
Are you with me? यहाँ पे plastic hinges form हो गए. Then will it be able to deform in this fashion?
Yes, sir.
Do you understand now that U2 and U1 are same?
Yes. Yes.
One of the situations. Are you with me?
Yes, sir.
There may be another situation where the building itself, imagine that it is a 2-story building. Can't it deform in this fashion? That means deformation is present only at the bottom story. It is also possible. When is this possible? When
Yes.
the upper story is very stiff in comparison with the bottom story. There is no much
Yes, sir.
relative displacement between the first story and second story. However, first story and ground story has significant displacement. Are you with me?
Yes, sir.
दो एग्जांपल्स मैंने दिए. कौन से? One is the formation of plastic hinges in this particular mechanism, and second one is the example something called a soft story, presence of a soft story. Are you with me? This story is
Yes,
called
sir.
a soft story because it is flexible in comparison with the upper story. We will discuss about this second example little later, but I hope now I have answered your question. Have I?
Yes. Yes. Yes,
Okay.
sir.
So we understand that U2 minus U1 is the quantity that is responsible for producing any stresses or strains in the columns of upper story. Are you with me?
Yes, sir.
Similarly, I can also represent the ground displacement as Ug of t. Are you with me?
Yes, sir.
However, in this particular case, Ug of t is always 0. That's what we are saying. And therefore, not in the event of seismicity. I am just considering a structure which is subjected to time-dependent load at first and second floor. At that time, ground is fixed. Ground is not going to move. Are you with me?
Yes, sir.
For example, let us say this building is subjected to wind load. Ground is not going to move, but the building is going to. Are you with me?
Yes, sir.
So in all such cases, Ug of t is always 0. So therefore, here also the responsible quantity for inducing stresses in column FG, EH and BA is in fact a relative displacement. Relative displacement of first story slab with ground. But Ug being
Yes, sir.
0, it is only U1 that matters for inducing stresses in FG, EH and B. Are you with me?
Yes, sir.
ओके. सो वी हैव अंडरस्टूड कि किसके वजह से कॉलम्स में स्ट्रेसेस आने वाले हैं. अपर स्टोरी कॉलम्स, द स्ट्रेसेस आर इंड्यूस्ड ड्यू टू रिलेटिव मैग्नीट्यूड ऑफ U1 विथ रेफरेंस टू U2. सो U2 माइनस U1 के वजह से स्ट्रेसेस इंड्यूस होने वाले. इफ यू लुक एट द बॉटम स्टोरी कॉलम, देन इट इज ड्यू टू U1 alone. Happy?
Yes, sir.
Now let me extend the question to forces in this damper elements. सो ये जो C1 और C2 ये डैम्पर एलिमेंट्स दिख रहा है, इसमें किसके वजह से फोर्सेस इंड्यूस होने वाले बताओ. कॉलम्स आर स्टीफनिंग एलिमेंट्स. डू यू एग्री विद मी?
Yes, sir.
However, these dampers, they don't have any stiffness, but the forces do get induced in them on account of what? डैम्पर एलिमेंट में फोर्सेस क्यों आते हैं? बिकॉज ऑफ वेलोसिटी. डू यू एग्री विद मी?
Yes, sir.
हाँ. सो नाउ टेल मी, दिस C2 एंड दिस एलिमेंट C2, इसमें फोर्सेस किसके वजह से आएंगे? So let me take a snapshot of this element C2 at time t. So let us say at time t equal to 5 seconds. कौन सा time लिया है मैंने? Time t equal to 5
5
seconds.
seconds.
I am going to draw this damping element. You have to understand that it is as if there is a horizontal cylinder which is filled with a fluid in which this piston moves and it experiences a force due to viscosity of a fluid. Are you with me?
Yes, sir.
So that force is proportional to what? It is proportional to velocity of this piston. Do you agree with me?
Yes, sir.
You drop a stone in water. We have considered this example. You drop a stone in water. As stone moves down, it starts accelerating. Its velocity starts increasing. Thereby, the drag force on it produced by the fluid on account of its viscosity also goes on increasing. Are you with me?
Yes, sir.
So you have to imagine that this piston is moving in this horizontal cylinder filled with a viscous fluid. Are you with me?
Yes, sir.
So force in this element will be dependent on what? It will be dependent on the movement of this velocity of this piston. Do you agree with me?
Yes.
This piston is connected with this top story, PE. Are you with me?
Yes.
So what is the velocity of this piston? Velocity of this piston moving in the cylinder is u1 dot of t. Do you agree with me?
Yes, sir.
So this piston is moving in this cylinder filled with a viscous fluid with velocity u1 dot of t. In the first place, is cylinder stationary? वो देखते हैं. It is connected to the ground. Is ground stationary?
Yes.
As the ground is stationary, the cylinder is also stationary. So force in this cylinder is on account of this velocity u1 dot of t. Do you agree with me?
Yes, sir.
So we have understood now कि C2 में किसके वजह से force आने वाले. Happy?
Yes, sir.
Now I will extend the question to what causes force in C1. C1 में क्यों force आएगा? तो अब जरा यहाँ पे ध्यान दो. Now the story is different. You have a cylinder like this, horizontal cylinder filled with a liquid, viscous liquid. In that you have a piston moving to and fro. Happy?
Yes.
This is connected. This piston is connected to BE. This piston is connected to CD. Are you with me?
Yes, sir.
And what is the velocity which with this piston moves?
U2 dot.
U2 dot of t.
Yes.
Happy? And what is the velocity with which the cylinder will move now? Is it stationary
U1
or is
dot
it
of.
also moving? Yes, it is moving because it is connected to BE. Are you with me? And this itself is moving with the velocity u1 dot of t. I have shown u1 dot of t and u2 dot of t towards right. That is the assumption. But if at the end of analysis you get u1 dot of t to be negative, that means it must be moving towards left. Happy?
Yes, sir.
So without loss of generality, can I write what will be the force in this C2? It will be on account of u2 dot minus u1 dot. Do you agree with me?
Yes, sir.
Okay, great. So we have understood that the forces induced in these columns, they are due to u1 for the ground story columns and they are due to u2 minus u1 for the upper story column. And we have also understood that C1 में जो force आएगा that is due to U2 dot minus U1 dot and C2 में जो force आएगा that is due to U1 dot alone.
U1 dot. Yes.
Because UG dot of T is always 0 in this particular case. Happy?
Yes, sir.
Okay. So कितने questions के answer दे दिए हमने? What are the degrees of freedom that are of our interest? So those are 2 degrees of freedom. Second question that we answered, what causes forces in which type of element? Happy?
Yes, sir.
Okay. Now let us try to write down the equation of motion. You have to imagine this system is a peculiar one where I can idealize entire mass of building to be lumped only at 2 locations. One is first floor, second is second floor. Are you with me?
Yes, sir.
Even the columns are going to have mass, but that mass is going to be insignificant in comparison with the mass of slab. Are you with me?
Yes. Yes, sir.
So half of the mass of this column I will add it to the upper slab and half I will add it to the first story slab. Happy?
Yes, sir.
Okay. So that's how these M1 and M2 are to be calculated. So we know that the mass is lumped at only 2 locations, M1 and M2. The degrees of freedom that we are monitoring are, okay, I will call this as M2 to be consistent and this as M1. Are you with me?
Yes, sir.
So degrees of freedom that we are interested in are x directional motion of m1 at all instances of time during the period of observation, and x directional displacement of mass m2 at all instances of time during the period of observation. Do you agree with me?
Yes, sir.
Okay. Now, to write down the equation of motion, that means it is the equation that will help us estimating u1 of t and u2 of t. I will have to apply Newton's second law. ये हमने पहले भी किया है. Do you agree with me? So
Yes, sir. Yes, sir.
so we are going to now apply Newton's second law first to mass m1. Are you with me? And then we are going to
Yes, sir.
apply Newton's second law to mass m2. अच्छा, न्यूटन सेकंड लॉ किसको अप्लाई किया जाता है बोलो? इज इट अप्लाइड टू ए मास और इज इट अप्लाइड टू ए फ्री बॉडी डायग्राम?
Free body diagram.
So therefore the first step that I need to do is to draw free body diagram of mass m1. Happy?
Yes, sir.
That's what I am going to draw first. FBD of m. What is free body diagram? Free the body from all external agencies and show what the external agencies must have been doing. इसको हम free body diagram. Are you with me?
Yes, sir.
So what is the first external agency to mass m1? Earth. Are you with me?
Yes. Yes, sir.
I free the mass from Earth and I must show what the Earth must have been doing. तो क्या करना पड़ेगा? Earth must be pulling it down with the force equal to mg, m1g. However, incidentally, we are going to write down we are concerned about the motion along x direction. Do you agree with me?
Yes.
So will this force matter? No, because we are going to
No.
write Newton's second law in x direction. However, for completeness, I have shown this force as well on the free body diagram. So similarly, I will have to show the forces offered by the columns. So where is mass m1? Mass m1 is here. So कितने columns के ऊपर ये supported है? There are 3 columns: BA,
Free
EH, and FG.
EH.
So I will also
FG.
have to show these 3 forces. Do you agree with me?
Yes, sir.
And that is going to complicate my free body diagram. Therefore, I choose not to represent any vertical actions on mass m1. Happy?
Sir.
So I am not going to show anything that is in vertical direction. I am going to show everything that happens in horizontal direction. Now, tell me, in this free body diagram, when mass m1 tries to move towards right, I have to show all the forces exerted by these columns on mass m1. What are the columns that are external to this mass m1? CB, TE, BA, EH, and FG. Do you agree with me?
Yes, sir.
These are the columns which are external to this mass m1. And when am I drawing this free body diagram? It is not drawn at an arbitrary instant. It is drawn at an time instant t. Are you with me? So we are drawing
Yes, sir.
free body diagram of mass m1 at t. Happy?
Yes, sir.
Okay. Now what I am going to do is at time t, let me say that this is the deformed shape. Are you with me?
Yes, sir.
So at time t, this is the deformed shape that I am drawing. And I am going to draw the free body diagram of which mass? This,
M1.
this one. Are you with me?
Yes.
इस मास का free body diagram हम बना रहे हैं. This is m1. So I have freed the mass from all external agencies. Now, this deformation is u1 of t. Do you agree with me?
Yes.
So all the top points of these columns, they are displaced at time t by amount u1 of t. Do you agree with me?
Yes, sir.
Now, so I will consider one of the columns as representative one. So ये A B column में यहाँ पे दिखाता हूँ. In that A is fixed at bottom and B is moved by amount U1 of T. Agreed?
Yes.
So this is the deform shape. Happy?
Yes, sir.
If you have to move this column's top end by U1 of T, where will you apply a force? It needs to be applied at the top towards right. Do you agree with me?
Yes. Yes, sir.
Consequence, the reaction is going to be in opposite direction.
Opposite.
These two forces, they create clockwise couple. So therefore, consequence, a reaction must be produced anti-clockwise in nature here.
Anti-clockwise.
We are not much bothered about these reactions, though we know it is 6 EI delta upon L square. So it is
L square.
6 EI delta is U1 of T. Are you with me? Upon
Yes.
L square. What
L
is L?
square.
L is 4 meter for the first story columns, for the ground story columns. It is upon 4 square. And this is also 6 EI U1 of T upon 4 square. Do you agree with me?
Yes.
Okay. Now, what is the magnitude of this reaction? तो मैंने आपको बताया कैसे करना है. You have to add this both the moments with sign. Both are anti-clockwise, so they get added up. So total is 12 EI U1 upon 4
12.
square. Do you agree with me?
Mhm.
And then you have to divide it once more by the length, so that you get this as 12
L cube.
yes, 12 EI U1 of T upon
On a 4 cube.
Q. Both these reactions have same magnitude. Do you agree with me?
Yes.
Okay. So if you have to move the top of one of the column towards right, then you need to produce a force which is equal to 12 EI U1 of T by 4Q. तो अगर आपको तीन कॉलम्स को मूव करना है, तीनों के लेंथ सेम है, EI सेम है, so how much force will you require? 3 times 12 EI.
3 times 12 EI.
But now you have to understand that we are considering one bay, so इसके पीछे भी ऐसे ही 6 कॉलम्स, 3 कॉलम्स रहने वाले. Are you with me?
Yes.
If you look
Yes,
at
sir.
the 3D view of this slab will be supported at all 4 corners and at the middle locations on 2 sides. Are you with me?
Yes, sir.
तो इस M1 का अगर मैं प्लान ड्रॉ करूं, so this is the plan of M1. This is the floor slab. It is supported at one column here, one column here, one column here, another column here, another column here, and another column here. So total कितने columns है? So
6.
this is BA, then this is EH, column EH, and this is FG. और इसके
FG.
पीछे और 3 column होने चाहिए. Other, this mass cannot be suspended with a support only on one side. Are you with me?
Yes, sir.
So we make that assumption that there are total 6 columns, and then what is the force that you require to apply on this column top in order to produce this displacement towards right? Tell me. So total force you require to produce is equal to 6 times 12
12 EI.
EI into U1 of T. Are you with me?
Yes,
Divided
sir.
by 4 cube. इतना फोर्स लगने वाला है. हैप्पी?
Yes.
ये किसने किसके ऊपर लगाया हुआ फोर्स है बताओ. This force must be the force applied by the slab on the column. Agree with me? Soham, have I lost you? Soham, are you there? Soham, you are not unmuted. Can you speak now? I think he has lost his connection, so I will ask someone else. So maybe Shubham, can you unmute yourself? Shubham Gosavi.
Yes, sir.
Yeah. So this force, what we are talking about, is applied by what on what? Can you tell me that?
Slab to column.
Yes, it is
Force
applied
applied.
by the slab on the column. But in this free body diagram, what are we showing? We are showing the force applied by column on the slab. Are you with me?
Yes, yes, sir.
So यहाँ पे क्या दिखाना पड़ेगा? So here I will have to show by Newton's third law, this force must be exactly equal to this means the force applied by column on the slab must be equal in magnitude but opposite in direction. Do you agree with me?
Yes, sir.
So I will have to show this force in this fashion. Happy?
Yes, sir.
And how much is that? So that is equal to 72 EI. And now I will drop the argument t. We understand that u1 is a function of time and we are showing this u1 at time t. So I will simply write it as 72 EI u1 upon 4q. Do you agree with me?
Yes, sir.
Okay. Now, even columns BD and column E, what is the name that we are given? Okay. This is C, new position of C, and this is new position of D. So even columns BC and DE, they are going to apply force on the top of this mass M1. Do you agree with me?
Yes, sir.
वो हम कैसे कैलकुलेट करेंगे? तो उसके लिए आई एम गोइंग टू ड्रॉ द फ्री बॉडी डायग्राम ऑफ दिस कॉलम BC. तो BC कॉलम की फ्री बॉडी डायग्राम एज ए रिप्रेजेंटेटिव कॉलम आई विल ड्रॉ इट. आर यू विथ मी?
Yes, sir.
So this is B and this is C. Happy?
Yes, sir.
B will at given instant of time B would have moved by u1 of t. Are you with me?
Yes, sir.
u1 of t occurs at B, so it would have moved towards right by u1 of t. I assume that u1 of t is towards right, positive, and similarly I make one more assumption that u2 of t is also positive, so this C would have moved somewhere here. Are you with me?
Sir.
And I make one more assumption. What is the assumption that I make? u2 of t is greater than u1 of t. Are you with me? So what are
Okay,
the
sir.
assumptions
Yes.
that I have made till now? u1 of t is greater than 0. u2 of t is greater than 0. Not only that, u2 of t is greater than u1 of t. And I am making these assumptions because without any loss of generality. Because whatever equations that we derive, उसमें अगर ये condition satisfy नहीं हुए, तो sign is automatically adjusted. Are you with me?
Yes, sir.
Okay, so this is u2 of t. Now, so what is the deformed shape of this column? Deformed shape of this column is something like this. Agreed?
Yes, sir.
Now, can you tell me how much is this? This is u2 of t minus u1 of t. Agreed?
Yes, sir.
Okay. Now, let us try to proceed here. u2 of t minus u1 of t. So, if you have to displace the top end with reference to bottom end by amount u2 of t minus u1 of t, what is the force that you will require to produce here? It is 12 EI by L cube by 3 cube because the top story has the length of 3. Are you with me?
Yes, sir.
So 12 EI upon 3 cube multiplied by delta. But delta here is u2 minus u. Now I will drop the arguments t. We know that it is function of time t and we have taken the value at time t. So u2 minus u1. Happy?
Yes, sir.
Now this force is applied by whom on whom? This force is applied by the slab on the column. Do you agree with me?
Yes, sir.
कौन सा स्लैब सेकंड स्टोरी का स्लैब, बट वी आर ड्राइंग द फ्री बॉडी डायग्राम ऑफ फर्स्ट स्टोरी स्लैब. सो हमें ये फोर्स की कोई जरूरत नहीं है. वी हैव टू शो दिस फोर्स. डू यू एग्री विथ मी?
Yes, sir.
एंड दैट इज इक्वल टू 12 EI upon 3 cube into u2 minus u1. Happy?
Yes, sir.
Now this towards left is the force applied by the slab on the bottom of column CB. So what column CB must be doing on this slab? It must be applying an equal and opposite force. So it must be towards right of the same magnitude 12 EI upon 3 cube u2 minus u. Happy?
Yes, sir.
How many such columns are there? 4. Because on top story you have this one column, another column, and behind that you are going to have another pair of columns. Happy?
Yes, sir.
So total कितने columns हो गए? 4. And what is the force then? 4 into 12 EI upon 3 cube into U2 minus U1 towards right. Agreed?
Yes, sir.
तो वो लिख लेता हूँ मैं. क्या लिखूँ इसको? 4. So हो गया 48. 48 EI. Happy?
Yes, sir.
Upon 3 cube multiplied by क्या लिखूँ?
P of
U
U of U2 of
minus
T
U1.
U2 minus.
Happy?
Yes, sir.
अब जरा देखो मैं क्या करने वाला हूँ. I am going to replace this 72 EI upon 4 cube by K1. What is the substitution that I am going to make? K1 is equal to 72 EI by 4 cube. Happy?
Yes, sir.
And I am going to replace this 48 EI upon 3 cube by K2. So what am I going to call this as? K2 is equal to 48 EI upon 3 cube. Do you agree with me? This
Yes,
is
sir.
similar. This is just a mathematical substitution. I am going to call K1 as 72 EI upon 4 cube, K2 as 48 EI upon 3 cube. What is K1? K1 then can be viewed as the aggregate stiffness of ground story, and K2 can be viewed as aggregate stiffness of first story. Do you agree with me?
Yes, sir.
Okay. Having said that, now is this free body diagram complete? देखो हमारा हमने ये सब जो बकवास की है बाकी के आजू बाजू की, that is for this free body diagram. So जो free body diagram सबसे important है उसको मैं box कर देता हूँ. You have to understand that this is what we are trying to do. Happy?
Yes, sir.
ये free body diagram complete है क्या? वो बोलो. No. When you draw free body diagram of an accelerating object, you also show the acceleration. Are you with me?
Yes, sir.
तो statics के लिए ये free body diagram sufficient है. But as the object is accelerating, I am going to also show the acceleration of m1. And now there is no question of relative acceleration. It is acceleration of mass m1. Are you with me?
Yes, sir.
So what is the acceleration of mass m1? U1 double dot of t. Do you agree with me?
Yes, sir.
I make now third assumption that u1 double dot of t is also towards right without loss of generality. Are you with me?
Yes, sir.
तो क्या क्या assumptions हमने किए हैं? We have said u1 of t is positive, u2 of t is towards right, that is positive, and u2 of t is greater than u1 of t. And we have also made the assumption that u1 dot of t is positive and u2 u1 double dot of t is also positive. ये सारे assumptions है without loss of generality. Are you with me?
Yes, sir.
Have we shown all the forces? No. We have still not talked about forces in C1 and C2. Do you agree with me?
Yes, sir.
हाँ तो C1 और C2 में भी forces आने वाले हैं. Now avoid me for pardon me for this clumsiness in writing. I hope what we are doing is clear to you. Now let's try to find out what are the forces in C1 and C2 at that instant of time. Are you with me?
Yes, sir.
So अब C1 और C2 के forces देखेंगे. So C1 is connected, one end of the C1 is connected to ground. Happy?
Yes, sir.
And another end of C1. Sorry. This is the cylinder. And another end of C1, that is piston end, that is connected to the upper story. Happy?
Yes, sir.
So I am going to draw now the diagram only of ground story. This is connected to ground. What are the names? So थोड़ा सा slow जा रहे हैं हम, but intentionally जा रहे हैं. BA, EH and FG. Are you with me? So this is BA. This is EH. And of course you have FG. Happy?
Yes, sir.
FG. Now, at time instant t, this must have been displaced. ये ऐसे पूरा displaced हुआ होगा. Are you with me?
Yes, sir.
Each of these columns, they have displaced by some amount. And what is that amount? That amount is u1 of t. Are you with me?
Yes, sir.
and this mass m1 is exhibiting the velocity u1 dot of t. Happy?
Yes, sir.
And ground is experiencing the velocity ug of t, which is equal to 0. Happy?
Yes, sir.
So what is the velocity, relative velocity of this piston with reference to the fluid in this cylinder? The cylinder and fluid is stationary. Piston is moving with the velocity u1 dot of t. I assume that it is positive towards right. So therefore, the force in this member must be equal to C1 times u1 of t. Are you with me? u1 dot of t.
Yes, sir.
And as the piston is moving towards right, this fluid must be applying force towards left on this piston and through this piston on this mass m1. So this force must be applied towards left. Do you agree with me?
Yes, sir.
So therefore यहाँ पे मुझे एक फोर्स दिखाना पड़ेगा. कौन से तरीके का फोर्स जरा बताओ. This force will be equal
Yes.
to C1 multiplied by U1 dot.
One.
Happy?
Yes, sir.
And I am going to write it as U1 dot alone. I am not going to write it as U1 dot of t. It is understood that it is calculated at time instant t, at which you are going to draw this free body diagram. Happy?
Yes, sir.
Okay. If anyone has doubt at any step, then you should ask me there, then and there itself, because it is very crucial to understand this. चलो अब आगे चलते हैं. Now this C2 element, by the way, I will have to also change the nomenclature. I will have to call this as C1 and I'm going to call this as C2. Are you with me?
Yes, sir.
So let us call this as C1 and let us call this as C2. To be consistent with the notations of M1, M2, I'm going to call this as C1 and I'm going to call this as C2. Happy?
Yes, sir.
Okay. Now let us try to find out what is the force exerted by this C2 on M1. Happy?
Yes, sir.
तो उसके लिए यहाँ पे एक डायग्राम बना रहा हूं मैं. This is M1 at time instant t. So initially it was at this location and now it has moved by amount u1 of t. Are you with me?
Yes, sir.
And let me call this as BA. Let me call this column as EH. Are you with me?
Yes, sir.
Okay. And what has happened to the columns above? This distance, I am going to call it as u2 of t. Happy?
Yes, sir.
Now, see. So if you look at, this is the new location of base of the cylinder for this damper, and the piston is connected to the upper end. So what is the relative velocity with which this piston is moving in this fluid? It is moving with the velocity u2 dot minus u1. Do you agree with me? u1 dot.
Yes, sir.
And I assume that this u2 dot minus u1 dot is towards right. That means I make one more assumption that u2 dot is greater than u1. Happy? So what are the assumptions we have made till now? U1 is positive, U2 is positive, U2 is greater than U1, U1 dot is positive, U2 dot is positive, U2 dot is greater than U1 dot, U1 double dot is positive, U2 double dot is positive. These are the assumptions we have made till now. Are you with me?
Yes, sir.
And all these assumptions are without losing the generality. If negative sign emerges at the end of analysis, the forces are, the direction of forces is self-adjusting. Are you with me?
Yes, sir.
Now this u2 dot minus u1 dot is the relative velocity with which this piston moves towards right. So this piston must apply. So therefore, this piston must apply a force towards right on this fluid. Do you agree with me?
Yes, sir.
So towards right force will be applied on this cylinder, and this cylinder in turn will apply towards right force on this mass. Do you agree with me?
Yes, sir.
Okay. So therefore यहाँ पे जो force दिखाना पड़ेगा, I will have to show it towards right with the magnitude. क्या लिखो magnitude? It is C2 multiplied by
See,
U2 dot
you put on.
minus U1 dot.
You
Happy?
wonder.
Are you with me?
Yes, sir. Yes, sir.
Okay. Now let us write down the Newton's second law, and that gives us the first equation of motion. So let us write down the Newton's second law. कहाँ लिखूं? यहाँ पे ही लिख देता हूं. So when I apply Newton's second law to this FBD, what is the equation that I get? Both. So K2 into U2 minus U1 is towards right. Happy? So I will write those
Yes, sir.
forces towards right. K2 into U2 minus U1. This is towards right. Happy?
Yes, sir.
K1 into U1 is towards left. So I will have to write minus K1 into U1. Happy?
Yes, sir.
Then what is Newton's second law? By the way, Newton's second law states that algebraic sum of all the forces in x direction must be equal to mass of the body into acceleration in x direction. Happy? So we are now writing down the algebraic sum of all the forces. C1 U1 dot is towards left, so it is minus C1 U1 dot. Happy?
Yes,
And C2 into U2 plus C2 into U2 dot minus U1 dot is towards right. Happy?
yes, sir.
Okay. What else is remaining? Or कौन सा force है? Nothing. We have written down all the forces. This is the sum of all the forces. And towards on the right hand side, I should write it as mass, which is m1, into acceleration, which is towards right, and u1 double dot of t. Happy?
Yes, sir.
U1 double dot of t. Fine. So we have written down the expression. Let me take this expression down because we are going to require this to cast it in matrix form. So let me rewrite it. 1 minute. Where is the expression? Just a second. Let me take it here. And let me simplify this. कैसे simplify करेंगे? So we are going to collect all terms that involve first derivatives together, second derivatives together, and second derivatives together, and no derivative together. ऐसे करने का. So therefore we are going to take all these terms on the right hand side. So m1 u1 double dot will remain as it is. Are you with me?
Yes, sir.
Then when this term goes on the other side, it becomes plus k1 into u1. Are you with me?
Yes, sir.
Term यहाँ जाएगा तो हो जाएगा k1 into u1. Then you have this term which is minus k2 into u1, which goes on the other side and becomes plus k2 into u1. Do you agree with me?
Yes, sir.
So I will take u1 common. So I will have k1 plus k2 into u1. Are you with me? Rearrange
Yes,
terms.
sir.
K2 into U1 is negative. It goes on the other side, becomes positive. This K1 into U1 is negative, goes on the other side, becomes positive. So it is K1 U1 plus K2 U1. So U1 common, you have K1 plus K2. Happy?
Yes, sir.
So this term is taken care of. This term is taken care of. Now we will write down K2 into U2. It goes on the other side and becomes negative. Happy?
Yes, sir.
And do you have any term in U2? No. So this is minus K2 into U2. Happy?
Yes, sir.
Okay. Now, what about this term C1 U1 dot? It goes on the other side and becomes positive.
Positive.
Are you with me?
Yes, sir.
That becomes positive. So it becomes, and then C2 into U1 dot. This is negative here. That side it goes and becomes positive. So I'm going to have C1 plus C2 into U2 dot. Happy?
Yes, sir.
Fine. Then yes, tell me next. C2 into U1 dot. C2 into U2 dot.
It
So
will
it is positive here. It goes on the other side, becomes negative. C2 into U.
negative. You to
Yes. This has to be U1 dot. I'm sorry. Happy?
Yes, sir.
Okay. So we have considered this term and we have considered कौन से वाला term? Both
C
these.
two.
Both these have been considered.
U-
This has to be equal to 0. Are you with me?
Yes, sir.
तो अब हम प्रॉब्लम स्टेटमेंट में एक और चीज ऐड करेंगे so that we write the final form of equation. Let us say that I have applied force F1 of t, F2 of t at the top. Are you with me? And I have applied time dependent force F1 of t at the bottom. This story. Are you with me? So free body diagram में change
Yes, sir.
क्या होगा? Free body diagram में you are also going to have F1 of t here. Happy?
Yes, sir.
So that time dependent force F1 of t comes into the picture and I will have to write it as this. What will be the change? This will be M1. Here it will be plus F1 of t. Are you with me?
Yes, sir.
And as we have taken everything on the right hand side, this F1 of t remains positive. So it becomes F1 of t. Are you with me?
Yes, sir.
तो देखो जैसे हमने सिंगल डिग्री ऑफ फ्रीडम सिस्टम के लिए इक्वेशन लिखा था उसी तरीके का एक इक्वेशन मिला है. Do you agree with me? We have terms in double derivative of u, we have terms in single derivative of u, and we have terms in no derivative of u. Are you with me?
Yes, sir.
नो डेरिवेटिव वाले टर्म्स स्टिफनेस के साथ एसोसिएटेड है. फर्स्ट डेरिवेटिव वाले टर्म डैम्पिंग के साथ एसोसिएटेड है एंड सेकंड डेरिवेटिव वाले टर्म्स मास के साथ एसोसिएटेड. Do you agree with me?
Yes, sir.
And on the right hand side as usual we have a forcing function which is f of t, f1 of t. Happy?
Yes, sir.
तो अब ये इक्वेशन देखो और जरा मुझे इसमें बताओ कि what all is time dependent and what all is not. इसमें is m1 time dependent? No. Do you agree with me?
Yes, sir.
We consider m1 to be constant. Is u1 dot of t time dependent? Yes. C1 plus C2 constant, u1 dot of t time dependent, C2 constant, u2 dot time dependent, K1 plus K2 constant,
Constant.
u1 time dependent, K2 constant, but u2 time dependent. Are you with me?
Yes, sir.
Okay, so I am going to call this now as equation number 1. Tell me, can you solve this equation the way we solved it for single degree of freedom system? No, because you have two unknowns coupled here. You have u1 dot as well as u2 dot. Do you agree with me?
Yes, sir.
हाँ, तो अगर इक्वेशन डिफरेंशियल इक्वेशन ऐसे रहता है लेट अस से ax डबल डॉट प्लस bx डॉट प्लस cx इज इक्वल टू सम फंक्शन ऑफ टाइम. ये इक्वेशन तो सॉल्व किया जा सकता है knowing the boundary conditions. Are you with me?
Yes, sir.
However, if you have equation like ax double dot plus bx dot plus y dot plus cx plus y equal to f of t, इस इक्वेशन को हम कैसे सॉल्व करेंगे? There are two differential equations inbuilt in this single one. Do you agree with me?
Yes, sir.
You have differentiation of x with reference to time. You also have differentiation of y with reference to time. वही यहाँ पे हो रहा है. You have u1 double dot u1 dot and u1, but you also have u2 dot and u2, which are functions of time. You agree with me?
Yes, sir.
So ये जो डिफरेंशियल इक्वेशन है, इसको हम बोलते हैं कपल्ड इक्वेशन. Are you with me?
Yes, sir.
This equation is coupled. In this, you have double derivative, you have single derivative and no derivative of both the degrees of freedom. एक ही डिग्री ऑफ फ्रीडम में लिखा हुआ इक्वेशन नहीं है. Do you understand? Are you with me?
Yes, sir.
So इसके साथ I was discussing शुभम के साथ. शुभम, now you can go on mute. Soham, can you once
Okay.
again unmute yourself?
Yes, sir.
Yes. Have you understood till this point? Soham? Soham, I lost your voice. Okay, then probably I will ask Omkar. Omkar, can you unmute yourself? Omkar Tapkir, can you unmute yourself? No response in chat box. No response here. I will assume the student is not present, and I am going to put them in waiting list. So Omkar, are you there? No. So I am going to put him on waiting. Nikhil, are you there? Nikhil Patil. Simply switching on the meeting without attention here will not do. So no response in chat box, no response on microphone. Nikhil, I am going to put you in lobby. Are you there? No. Shreyas, are you there?
Yes, sir.
Yes. Okay. Keep yourself unmuted. Have you understood till this point?
Yes, sir.
Okay. So these are called as coupled equations where we have derivatives and no derivatives of both the degrees of freedom coupled in a single equation. Now we are going to go ahead and we are going to write down the second differential equation. Are you with me? Shreyas?
Yes, sir.
Okay. So let us go ahead and now apply Newton's second law to mass M2. So FBD of mass M2. So to do that, I am also going to show mass M1 here. Are you with me? And this is mass M2 here. This is mass M2. Mass M1 has displaced from its original position by amount del U1 of T. So we are drawing this FBD at time T. And this mass M2 is displaced by amount U2 of T. Are you with me, Shreyas?
Yes, sir.
Okay. And of course, we are going to have a damper element here. So that damper element let me denote in this fashion, and this is seat. Happy? And let me draw the free body diagram of this mass M2 here itself. So all the force, I am going to free it from Earth, but I will not show M2 into G because it is in Y direction. I am going to free it from these columns. Now, when I free it from these columns, what is the force that is experienced by M2 due to this column? So I am not going to redo all that. It is going to be towards left because on columns M2 applies force towards right. So columns are going to in turn apply force towards left. And how much is that force? We have already calculated that force has to be equal to 1, 2, 3, 4, total 4 columns. So 48 EI upon L cube, which is 3 cube, multiplied by relative displacement U2 minus U1. Do you agree with me, Shreyas?
Yes, sir.
Have you understood how this expression has come?
Yes, sir.
Okay. Now, what is the force in this damper element? So again, we know that it is going to be uh, u2 minus u2 dot minus u1 dot. So relative velocity of this plunger toward is going to be towards right with reference to the cylinder. So therefore, the fluid must apply force towards left, and therefore I'm going to write down that force towards left. I'm going to write it as C2 multiplied by u2 dot of t minus u1 dot of t. Are you with me, Shreyas?
Yes, sir.
Okay. And what is the acceleration of mass m2? I assume that acceleration of mass m2 at time instant t is going to be equal to u2 double dot of t towards right without loss of generality. Are you with me?
Yes, sir.
So now can we apply Newton's second law, algebraic sum of all the forces? Now, by the way, this 48 EI upon 3 cube, I have already called it as K2. You remember that? देखो यहाँ पे I had made a substitution where I had called 48 EI upon 3 cube as K2. So therefore, I am going to call this as K2. Happy?
Yes, sir.
So summation fx. So what is summation fx? Minus K2 into U2 minus U1. Happy?
Yes, sir.
And then minus C2 into U2 dot minus U1 dot. Happy?
Yes, sir.
This must be equal to, of course, I have to show force F2 of T acting here. So this must be equal to plus F2 of T, F2 of T. This must be equal to mass M2 into acceleration U2 double dot. Happy?
Yes, sir.
So I have applied Newton's second law at time instant t to this free body diagram of mass m2. Now let us simplify it. So if I simplify it, what is the result that I get? So m2 u2 double dot, and then this k2 goes on the other side, so it becomes plus c2 into u2 dot minus u1 dot. Happy?
Yes, sir.
And plus k2 into u2 minus u1. Happy?
Yes, sir.
This must be equal to F2 of t. Are you with me?
Yes, sir.
So let us take this equation there. This is the second equation that we have. This is the second equation. Is this a coupled equation? Yes, because it involves u2 dot minus u1 dot and u2 and u1. So both the equations of motion that we have derived are coupled. Do you agree with me?
Yes, sir.
And we are not in a position to solve this because we are in the position to solve decoupled equations. We could solve this equation if it would have been m1 u1 dot plus c u1 dot plus k u1 equal to f of t. अगर ऐसे रहता तो हम इसको solve कर सकते थे. But as it involves u1 dot and u2 dot both, it involves u1 and u2 both. I cannot solve this. Are you with me?
Yes, sir.
Okay. So we are going to now represent these equations in matrix form. Are you with me?
Yes.
तो मैट्रिक्स फॉर्म में कैसे हम रिप्रेजेंट करेंगे? सो आई एम गोइंग टू कॉल दिस एज u1 डबल डॉट u2 डबल डॉट, then we are going to consider some matrix multiplied by u1 dot u2 dot, excuse me,
Yes, sir.
plus some matrix multiplied by u1 u2, and this is equal to f1 of t and f2 of t. Happy?
Yes, sir.
अच्छा, तो पहले वाला इक्वेशन हमें लिखना है. सो व्हाट इज द फर्स्ट इक्वेशन? टेल मी. m1 u1 डबल डॉट, so it is going to be m1 u1 double dot, then सेकेंड रो में जो सेकेंड एलिमेंट जो यहाँ पे रहेगा, it gets multiplied by u2 double dot. But is there anything of u2 double dot in first equation? No. So therefore it is m1 into 0. Do you agree with me?
Yes, sir.
M1 and 0. So m1 u1 double dot plus 0 u2 double dot plus what is the coefficient of u1 dot? u1 dot का coefficient है c1 plus c2. Do you agree with me?
Yes, sir.
And what is the coefficient of u2 dot in the first equation? u2 dot का first coefficient in first equation is minus c2. Happy? तो देखो c1 plus c2 into u1 dot minus c2 into u2 dot. तो हम यहाँ तक आ गए. Now, what happens to the stiffness matrix? Coefficient of u1 is k1 plus k2. Happy?
Yes, sir.
And coefficient of u2 is minus k2 is equal to f1 of t. So I have recovered the first equation. Do you agree with me?
Yes, sir.
Now let us recover the second equation. You have m2 u2 double dot. You don't have anything corresponding to u1 double dot. So therefore 0 into 0 and m2. 0 u1 double dot plus m2 u2 double dot. Matrix multiplication is what we are doing. We are multiplying. We are writing down the second row. So 0 into u1 double dot plus m2 into u2 double dot plus यहाँ पे क्या लिखूं? What is in the second equation? What is the coefficient of u1 dot? It is minus c2. Do you agree with me? देखो.
Yes, sir.
What is the coefficient of u2 dot? It is c2.
C2.
What is the coefficient of u2? k2.
K2.
And what is the coefficient of u1? Minus k2. Happy? Are you with me?
Yes, sir.
Now tell me which of these matrices are time dependent and which of the matrices are not. This my matrix m1 0 0 m2 is not dependent on time. However, u1 double dot and u2 double dot are functions of time. Are you with me?
Yes, sir.
c1 plus c2 minus c2 minus c2 c2 is not dependent on time. However, u1 dot and u2 dot, they are dependent on time. Happy?
Yes, sir.
K1, this stiffness matrix K independent of time, but u1 and u2 are dependent on time. And this forcing function, it is also a function of time. So we have now bifurcated this equation into two quantities, one which are time independent, another which are time dependent. Are you with me?
Yes, sir.
Now, the first matrix, we call it as mass matrix. Are you with me? Because it involves all the elements in terms of mass. Happy?
Yes, sir.
Then second matrix, we call it as damping matrix because it involves linear combinations of damping coefficients. Are you with me? So what will be the name for the third matrix? Tell me. Yes, shares. What will be the name for this matrix? Are you there?
So stiffness.
Yes. So it is stiffness matrix because it involves linear combination of stiffness terms.
Yes, sir.
Are you with me? What are the properties of stiffness matrix that we have learned? Stiffness matrix must be positive definite. That means its diagonal elements must be positive. Do you agree with me?
Yes, sir.
So are diagonal elements positive? Yes. And stiffness matrix must be symmetric. Is it symmetric? Yes, it is symmetric.
Yes, yes,
If
yes,
the
sir.
stiffness matrix turns out to be asymmetric, you are making an error. Are you with me?
Yes, sir.
So all the properties of stiffness matrix have been respected. And finally, I have got this equation where mass, damping, and stiffness matrices are independent of time. However, first, second, and no derivatives of degrees of freedom are dependent on time. Happy?
Yes, sir.
Okay. Now, these equations are, now tell me, correspond in mass. When you wrote mass matrix, पहले इक्वेशन में u1 डबल डॉट के साथ u2 डबल डॉट था क्या? नहीं था. Do you agree with me?
Yes, sir.
सेकेंड इक्वेशन में u1 डबल डॉट था क्या? नहीं था. So consequence of not having the corresponding derivative terms of other degrees of freedom, other degree of freedom is that matrix becomes diagonal. Are you with me?
Yes, sir.
When I was talking about the first equation and the term u1 double dot, उसमें u2 double dot की term नहीं थी. Consequence, mass matrix has become diagonal. Are you with me?
Yep.
Now consider u1 dot. When I wrote the term of u1 dot, that equation also had term of u2 dot. Are you with me?
Yes, sir.
When I wrote something about u2 dot, that equation also had term of u1 dot. Consequence, damping matrix is non-diagonal. Are you aware of what is diagonal matrix? Only diagonal elements are non-zero. Are you with me?
Yes, sir.
Now, when you talked about u1 wala term, you had u2. When you talked about u2 wala term, you had u1. Consequence, stiffness matrix is non-diagonal. Happy?
Yes.
Are you with me?
Yes, sir.
अब जरा यहाँ पे ध्यान दो what I am trying to say. Somehow, by some trick of magic or by some trick in trade, if I convert these equations into diagonalized form, समझ में आ रहा है मैं क्या बोल रहा हूँ? I apply some transformation. I do something. For example, let us say if it is a geometry and I am writing down the equation of line. If I shift the origin, you get the new equation, right?
Yes, sir.
वैसे ही अगर मैं यहाँ पे कुछ ट्रांसफॉर्मेशन अप्लाई करूं, व्हाट इज दैट ट्रांसफॉर्मेशन? दैट इज अ मैजिक वॉन्ड. दैट इज अ मैजिक वॉन्ड. वो बाद में देखेंगे क्या है. आर यू विद मी? But if I apply that transformation and somehow all these matrices become diagonalized, वो ट्रांसफॉर्मेशन अप्लाई करने के बाद अगर ये हो जाए कि ये मास मैट्रिक्स तो डायगोनल ही रहे बट विथ न्यू एलिमेंट्स व्हिच आर डिनोटेड बाय कैपिटल एम. आर यू विद मी?
Yes, sir.
And as I have applied the transformation, it will not be now u1 double dot and u2 double dot. It will be the transformed degrees of freedom. I'm going to call it as z1 double dot and z2 double dot. So what is the transformation I'm applying? I'm applying some transformation which changes u1 double dot to z1 double dot and u2 double dot to z2 double dot. Are you with me?
Yes, sir.
I know that transformation. That is like a mathematical equation. I know the mathematical relationship between u1 double dot and z1 double dot. I know the mathematical relationship between u2 double dot and z2 double dot. It is known. Believe me for some time that it is known. Such that when I transform this system of equations in this system, it becomes this way. Where these capital C1 and C2 are damping in this coordinate system. Are you with me?
Sir.
Plus capital K1, 0, capital K2, Z1, Z2, and these are now also the transformed forces. So I am going to call it as F1, capital F1 of T and capital F2 of T. Are you with me?
Yes, sir.
If I am successful in doing that, now what happens? Now the coupled equations have transcended into decoupled equations. Now you have two equations, m1 z1 double dot. चलो इसको हम expand करते हैं. m1 z1 double dot plus z0 into z2 double dot plus c1 z1 dot plus 0 into z2 dot. Are you with me?
Yes, sir.
Plus k1 into z1 plus 0 into z2. K1 into Z1 is equal to capital F1 of T. And similarly, you are going to have second equation, M2 Z2 double dot. Are you with me? Plus C2 Z2 dot plus K2 Z2 is equal to F2 of T. Happy?
Yes, sir.
And now we already know how to solve these two equations. Do you agree with me?
Yes, sir.
It is as if solving two single degrees of freedom. Are you with me?
Yes, sir.
So therefore अब यहाँ पे ध्यान दो. The entire focus of analysis of multi-degree of freedom system lies on finding out this transformation which will decouple these equations of motion. Are you with me?
Yes, sir.
तो वो होने के बाद then I can solve it as if it is two single degree of freedom systems I can come up with what is the expression for z1 of t, what is the expression for z2 of t as a solution, and then I can apply inverse transformation to get u1 of t and u2 of t. Are you with me?
Yes, sir.
Jesse, if I say that u1 double dot of t is 4 times z1 double dot of t, so what is z? So if I know z1 double dot of t, I will apply the transformation to get u1 dot of double dot of t. Are you with me?
Yes, sir.
So अब हमारा पूरा फोकस किसमें रहने वाला है? We have to find out that magic, that transformation which transcends this coupled equation into decoupled equations. Are you with me?
Yes, sir.
तो यही हमारा फोकस रहने वाला है. आज हम यहाँ पे ही रुकने वाले हैं, but we will set right at this onset all the terminologies that we are using, and then we will stop for today. So what is this mass matrix is called? As we are writing down it in an original coordinate system where equations are coupled, we call this as generalized mass matrix. Are you with me?
Yes, sir.
Generalized. So whenever I assign the word generalized, it means that I am writing down the matrices in original system where the equations are coupled. I'm sorry. Whenever I'm simply writing them as mass matrices or damping matrices or stiffness matrices, it means that these matrices are written in the original system. Are you with me?
Yes, sir.
Where equations are coupled. But when I apply a transformation such that these equations transcend themselves into a decoupled way, then corresponding matrices, I'm going to call them as generalized mass matrix. Are you with me?
Yes, sir.
So this is generalized mass matrix. This is generalized damping matrix. And this is generalized stiffness matrix. Are you with me?
Yes, sir.
So when I transform the original coordinate system to generalized coordinate system, I get decoupled equations. Are you with me?
Yes, sir.
We have understood the concept. Mathematics of it is related to solving the eigenvalue problem. So we are going to do that in the next class. I expect that by the next class, you should go and read what is eigenvalue problem. Are you with me?
Yes, sir.
So what is your homework? Next class के पहले आपको क्या देखना है? You have to understand what is eigenvalue problem. Happy?
Yes, sir.
Okay, so this is the philosophy. Before we close for today, now I'm going to ask you the last question for today. Looking at these equations of equilibrium, can you represent this system as a spring, mass and dashpot system? Easily. कैसे? देखो अब this is K1, this is C1, this is M1. Are you with me?
Yes, sir.
And you have this as K2, K1 और K2 के वैल्यू हमारे पास ऑलरेडी है. Are you with me?
Yes, sir.
This is C2 and this is M2. This is the representation of that two-story, one bay at ground, two bays at ground and one bay at top. वो जो frame है, इसका ये representation है. Where I apply F1 of T here. I have applied F2 of T here. Are you with me?
Yes, sir.
And what are the degrees of freedom that we are monitoring? We are going to monitor degree of freedom U1 of T, and we are going to monitor degree of freedom U2 of T. You are free now to draw free body diagrams of M1 and M2 and see whether you recover the same equations of motion or not. वो आप करके देख सकते हो. But if you see any such kind of system, what is the corresponding equation of motion? It is M1 0, 0 M2. Are you with me?
Yes, sir.
U1 double dot of T, U2 double dot of T plus C1 plus C2 minus C2 minus C2 C2 this into U1 dot and U2 dot. Happy?
Yes, sir.
अच्छा प्लस बोलो क्या लिखूं? K1 plus
K1 plus
K2
K2,
minus K2
K2,
minus K2 and K2.
K2.
तो जब भी आप ये सिस्टम देखते हो तो बिंदास ये इक्वेशन लिखना है. आर यू विथ मी?
Yes, sir.
u1, u2, and this has to be equal to f1 of t, f2 of t. Happy?
Yes, sir.
Okay. Just a second. Now, can we solve these equations without boundary conditions or initial conditions? No, these are both equations are second degree equations. Are you with me? So, how
Yes,
many
sir.
total boundary conditions will you need? You will need 4 because you have second order differential equations but 2 differential equations. So, therefore, total 4 boundary conditions are needed. Are you with me?
Yes, sir.
So therefore देखो बाउंड्री कंडीशन किस तरीके से होगी u1 of 0 that is u1 at time t equal to 0 is u1 0. Are you with me? u2
Yes,
of
sir.
0 that is m2 का displacement at time t equal to 0 is u2 0. Happy? u1 dot of 0 that is velocity of mass m1 at time t equal to 0 is u1 dot of 0 and that is u1 0 dot. Happy?
Yes, sir.
And velocity of mass 2 at time t equal to 0 is u2 0. These 4 quantities must be known. Then and then only you can solve these 2 differential equations. So this both things, one this matrix representation of differential equations and these boundary conditions together translate this physical problem into mathematical domain. Are you with me?
Yes, sir.
So these are the standard notations that we will be using. And we are going to solve this problem in tomorrow's class. However, I am not going to solve this problem with this M1, M2 letters. No, instead of that, I am going to give you values so that you will be able to interpret the result, plot the result, and then make something out of it. So therefore, we are going to take values of M1, M2, just like we did it for single degree of freedom system. And then we are going to solve it for that system. Are you with me?
Yes, sir.
Okay. So we will close with the final remark. Final remark is this. The entire focus of analysis of multi-degree of freedom system is decoupling the equation of motion such that the system can be analyzed as 2 single degree of freedom systems. Why 2? Because here degree of freedom is 2. If it is n degree of freedom system, then we are going to apply something such that it can be analyzed as n number of single degree of freedom systems. Are you with me?
Yes, sir.
Okay. So with this, let us close it for today. If anyone has any doubt, please ask me now. You can use the same link to mark your attendance.
So, excuse me,